What is the value of k? Given that you have k to the power of 12 equals 2 to the power of 12. Then let's have it to be solution from here. Recall that when we have a to the power of m that equals b to the power of m, so far they have the same power. This implies that a equals b. So applying it here as well, we have k to the power of 12 equals 2 to the power of 12. This also implies that k equals 2 to be the first real solution. But I must tell you that k equals 12 is not the only real solution from here. Then let's solve for the others. So we have k to the power of 12. Let's say this to the others here. We have 2 to the power of 12. Then let's set them to be equals 0. Let's write 12 as 6 times 2. So here will be k to the power of 6 times 2 minus 2 to the power of 6 times 2 will give us 12. Then we should set them to be equal 0. So when we have a to the power of m times n, this will be equals a to the power of m in parentheses to the power of n, and this can also be simplified as a to the power of n in parentheses to the power of m. So when we apply it here, we can have here to be k to the power of 6 in parentheses to the power of 2 minus 2 to the power of 6 in parentheses to the power of 2. Then this will be equal 0. Mind you, this is a perfect square because of these 2 and 2 here. So when we have a to the power of 2 minus b to the power of 2 as a perfect square as this, it can be simplified as a plus b in parentheses multiplied by a minus b in parentheses. So when we have our a equivalent to k to the power of 6 and our b equals 2 to the power of 6. So definitely here will be k to the power of 6. Here will be plus b 2 to the power of 6. Multiply by, here will also be k to the power of 6 minus 2 to the power of 6 as this. Then we set everything to be equal 0. Now, for this expression to be equal 0, because they are connected with products, is either we have k to the power of 6 plus 2 to the power of 6 equals 0, or we have k to the power of 6 minus 2 to the power of 6 equals 0. So from here, let's say we have this to be k to the power of 6 equals minus 2 to the power of 6. It is obvious for any value of k, here, this left hand side cannot be negative. It will always be positive. And here is negative. So meaning that this cannot be equal to this. So we reject this. Then let's go along with k. We can also simplify this as k to the power of 6 will also be equal to the power of 6. And k will be also equals to the same as the previous solution. But we can still solve this one further. This will be k to the power of 2 times 3 minus 2 to the power of 2 times 3 equals 0. Where we are going to have this as k to the power of 3 in parentheses to the power of 2 minus 2 to the power of 3 in parentheses to the power of 2 equals 0. By applying the perfect square to this, we can also have it as. So when we have it as this, we call that a to the power of m times n equals as a to the power of m in parentheses to the power of n equals a to the power of n in parentheses to the power of m. So we can have this as k to the power of 3 in parentheses to the power of 2 minus 2 to the power of 3 in parentheses to the power of 2 equals 0. So from here, this is a perfect square. We can have this as k to the power of 3 plus 2 to the power of 3 multiplied by k to the power of 3 minus 2 to the power of 3 equals 0. And so by so doing, we can have here to be, let's say we have case 1, where we have k to the power of 3 plus 2 to the power of 3 equals 0. This is a sum of two cube. We call that when we have a to the power of 3 plus b to the power of 3 equals a plus b in parentheses multiplied by a square minus ab plus b square. So here will be k plus 2 in parentheses multiplied by k square minus 2k plus 2 to the power of 2 then equals 0. K plus 2 then multiply by this will give us k square minus 2k plus 4 equals 0. So for this expression to be equal 0, you see that we have k plus 2 equals 0, or we have k square minus 2k plus 4 to be equal 0. This implies that we have k to be equals 2, and so we have k to be equals minus b positive or negative root of b square minus 4ac all divided by 2a. So we have a to be the coefficient of k square, which is 1, and b to be the coefficient of k, which is minus 2, and c equals 4. So here will be k will be equals minus outside into parentheses minus 2, positive or negative, minus 2 in parentheses to the power of 2. 4 times a is 1 times c is 4, all divided by 2 times 1. So this will be equals k 2 positive or negative root of here will be 4. 4 times 1 is 4 times this will give us 16 divided by 2. We have k 2 positive or negative. 4 minus 16 will give us minus 12 divided by 2. When we have root minus a equals root of a times root of minus 1, so this will be k 2 positive or negative root of 12 multiplied by root of minus 1 divided by 2. We have k 2 positive or negative root 4 times 3 root of minus 1 equals I. Here will be I divided by 2. We have k to be equals 2 root 4 will give us 2 multiplied by root 3I divided by 2. So we have k. This divided by this will be 1, positive or negative. This will also cancel this. We have root 3i. And we have k to be equals minus 2. This will be the second solution for the first one we got. Then let us also solve for the second case. So we have difference of 2 cube when we have a to the power of 3 minus b to the power of 3 equals as a minus b multiplied by a square plus ab plus b square. So here will be k minus 2 in parentheses multiplied by k square plus 2k plus 4 equals 0. For this to be equal 0, is either we have k minus 2 equals 0, or we have k square minus plus 4 plus 2k plus 4 to be equal 0. From here, k will be equals 2. This justifies the previous solution. This, you can also have it as k minus b positive or negative root of b square minus 4ac divided by 2a, where we have a to be equals coefficient of k squared 1, b to be equals 2, and c to be equals 4. So we have k to be equals minus 2, positive or negative, minus 2 in parentheses, to the power of 2. 4 times a is 1 times c is 4 divided by 2 times 1. We have k minus 2, positive or negative. Root of this will give us 4 minus 16 divided by 2. Minus 2, positive or negative. Root of minus 2 minus 12 divided by 2. So k will be equals minus 2, positive or negative. This will be root of 12 multiplied by root of minus 1 divided by 2. So we have k. This will be minus 2, positive or negative. Root 12 will give us 2 multiplied by root 3i divided by 2. So we have k minus 2 divided by 2. This 2 divided by 2 multiplied by root 3i. K will be equals, this will cancel this, minus 1, positive or negative. This also cancel this. We have 3 root 3i. So this is the value of k. And we also have the value of k, 1, positive or negative, root 3i. This is a complex solution. Y, k equals 2, k equals minus 2, a real solution. So if you are new here and find this video interesting, don't forget to share, like, comment, and subscribe to our YouTube channel for more math tutorial videos. Bye bye.